Oh shit. It's totally awesome. Students, can you hear my voice? Adil. Okay. Sania. Sania, can you hear my voice? Can you hear my voice? Ganesh Sagar. Ganesh Sagar. Can you hear my voice?
Yes.
Okay, okay. So up to now, I didn't unmute. So why you are not telling? Just you are seeing, that's it. Okay, okay. And okay, children. Now, can you hear my voice? Okay, very good. Okay, see now equal sets. Equal, what are the equal sets? Equal sets nothing but if two sets are in the given two sets, if there are same elements, they are called equal sets. Okay. Can you hear my voice, all of you? Okay, children, can you hear all? Can you all hear my voice? Right, okay. So now see, now we are discussing about equal sets. See here, equal sets means if there are same elements in the given two sets, they are called equal sets. Okay. For example, see, A is equal to set of PQ given and B is equal to set of QP given. See, if we observe the elements in both sets, same elements are there. Okay, PQR, QPR, right? So like this, if there are same elements in the given two sets, they are called equal sets. So we write as A is equal to B. Okay, here see three examples are given. Observe these three examples. A is equal to set of Sachin, Dravid, Kohli. B is equal to Dravid, Sachin, Dhoni. C is equal to set of Kohli, Dravid and Sachin given. Can you say which two sets are equal here? Can you say which two sets are equal here? See, observe the first two sets. In set A, Sachin is there. In set B also Sachin is there. In set A, Dravid is there. In set B also Dravid is there.
Sir, see.
Set A, Kohli is there, but in set B, Kohli not there. Dhoni is there. So they are not equal. So if we observe set A and C, see these two sets are equal. See in set A, Sachin is there. In set C also Sachin is there. In set A, Dravid is there. In C also Dravid is there. In set A, Kohli is there. In set C, Kohli. In set C also Kohli is there. It means, so here set A and C both are equal. Why? Because there are same elements in the two sets. So like this, if there are two same elements in the given two sets, they are called equal sets. Did you understand? Let us see one example here. See, observe example 9. Observe example 9. See, A is equal to set of PQRS given, B is equal to set of 1, 2, 3, 4 given. Asking, are they equal? clearly we can say that they are not equal. Why? Because there are no same elements. Okay, in set A and set B there are no same elements, so they are not equal. Okay, and let us see the example 11. Example 11, observe this example 11. Set C is given, X is equal to X such that X is a letter in the word assassination. And set B is equal to X such that X is a letter in the word station. Right? So let us see whether they are equal or not. See, first of all, write them in roster form. Okay? So if we write them in roster form, first of all, set C. What elements will come in set C? See, I am writing here. If we write in roster form, so in according to definition of roster form, if we write once the element, again should not repeat it. Okay. So first of all, A. Next, S. See here, S is repeated so many times, but we should write only one time. Okay. And A also written, S also written, I. Next, N. T. Okay. And O. So these are the elements from set C. Okay. And from set B, see in set B, what elements we get? Set B is given X such that X is a letter in the word station. Okay. See what elements we get. First of all, S. Okay. T and I, O and N. Now observe the elements. A also is there, no? So here A also is there. Now observe the elements. What are the elements in set C? Same elements are there in set B. Okay, here see. This is set B and this is set C. See, same elements are there. C. Okay. So like this, if there are same elements in the given two sets, they are called equal sets. Okay, children. Right. Now, let us see exercise 2.3. Okay. All of you open exercise 2.3. See, the first question is given, which of the following sets are equal? The first question is given, which of the following sets are equal? Here, three sets are given. See, the first set, A is equal to X such that X is a letter in the word follow. B is equal to X such that X is a letter in the word flow. And C is equal to X such that X is a letter in the word wolf. Right. Three sets are given. So we have to say which sets are equal. Right. So let us see. Exercise 2.3. Okay. So the first question, given set A is given, set A is equal to X such that X is a letter in the word X such that X is a letter in the word follow. Okay. Next, set B is given. So here only write that roster form of this two set. So therefore, A is equal to X such that X is a letter in the word follow. So what elements we get here? Element F, O, L. See here, L is repeated 2 times, but should not write 2 times, only 1 time. Okay. And L after O. O also repeated 2 times, but should not write. And W. So this is the roster form of the given set. Okay. And set B is equal to, what is given set B? X such that X is a letter in the word, X such that X is a letter in the word flow. Okay. Now write the roster form of this set B. What we get? F, L, O, W. Here any alphabet didn't repeat. Okay. More than 1 time. And next C is equal to given. C is equal to given X such that X is a letter in the word wolf. Okay. Now write the roster form of set C. What elements we get? W, O, L, F. Here also no element repeated more than 1 time. Right. So these are the roster form of set A, B, and C. Now observe the set A, set B, and set C. Okay. So in which sets elements are same are there? Let us see here. In set A, the element F is there. Okay. In set B also F is there. And in set C also the element F is there. Right. Next, in set A, the element O is there. In set B also O is there. In set C also O is there. In set A, L is there. In set B also L is there. And in set C also L is there. In set A, the element W is there. In B also W is there. And in set C also W is there. It means in these 3 sets A, B, and C, same elements are there now. Okay. The elements are here and there, but same elements are there in set A, set B, and set C. So what can we conclude here? There are same elements. There are same elements in set A, B, and C. Okay. So there are same elements in set A, B, and C. So they are equal. So they are equal. It means A is equal to B is equal to C. So like this, equal sets means if there are same elements in the given sets, they are called equal sets. Okay. So have you all understood this problem? Have you all understood this problem? So if you understood, please show your thumb. Okay, very good, children. Now let us go to next problem. Now see the next problem. Second bit. Consider the following sets and fill up the blanks with equal or not equal so as to make the statement true. Okay. See children, set A is equal to given 1, 2, 3. and set B is equal to given the first three natural numbers. Are they equal? Yes, we can say they are equal. Why? Because they are equal. A is equal to B. Why? Because see, in set A, 1, 2, 3 elements are there. In set B, if we write the elements, first three natural numbers, what elements we get? 1, 2, 3 only. No? 1, 2, 3 are the first three natural numbers. Okay. In set A, same elements are there. In set B also same elements are there. So the A is equal to B. And see here, second one. Set C is equal to given A, B, C, D. D is equal to D, C, A, B given. Now check out whether the elements are same or not. See, A is present in set C and also in set D. B is there, B also is there. C is there, C is there. And D is there, here also D is there. Okay, same elements are there. So here we can say that C is equal to D. Right, these two sets C is equal to D. And see here, E is equal to AEIOU, F is equal to set of vowels in English alphabet. What are the vowels in English alphabet? AEIOU. Okay. So these two sets are equal, E and F. Now here some blanks are given. First A and B. Are they equal, A and B? Yes. They are equal. Write equal symbol. Second one, A and E given. Are they equal, A and E? Set A and set E. In set A, 1, 2, 3 elements are there. In set E, AEIOU is there. Are they equal? No, they are not equal. Set A and E not equal. Now C dash D given. Set C and set D, are they equal? Yes, they are equal. Next D and F given. D dash F. Are they equal, D and F? Set D given DCAB and F is given AEIOU. Are they equal? No, they are not equal. So like this, if the two sets are equal, write equal symbol. If they are not equal, write not equal symbol. Right? The same way remaining, you complete, children. Now, let us see the third bit. In each of the following, state whether A is equal to B or not. Okay. So, can we say A is equal to B here? A, B, C, D is there. Here also A, B, C, D is there. Yes, these two sets are. 12, 16 is there. Here also 8, 4, 16, 18 is there. Are they equal? If we observe these elements in the sets, in set A 4 is there, here also 4 is there. 8 is there, but here 8 is there. 12 is there, but in this 12 not there. It means here A is not equal to B. It means elements are not equal in the given two sets. Okay. 12 is not present in the set B. Okay. So they are not equal. The same way, now you complete this remaining two problems, children. Okay. And also here, the fourth bit, it is given, state the reasons for the following. Set of 1, 2, 3 dash dash 10 given is not equal to x such that x belongs to n and 1 less than or equal to x less than or equal to 10 given. Okay. So why they are not equal? Just you write them. Okay. And see the fifth bit, list all the subsets of the following sets. Okay, asking here, write the subsets of the following sets. Subsets, how we can write the subsets, already we have discussed. So I will explain only one problem in this. Remaining you have to write. See this last problem I will explain 10, 100, 1000. Okay. Okay, see here. I will explain this second problem. C is equal to set of x, y, z given. Okay, C is equal to set of x, y, z given. Right? So what is asking here? List all the subsets. Okay. So we all know that while writing subsets, according to definition of subset, first of all, we have to find the number of subsets. Number of subsets. To find number of subsets, we have the formula that is 2 power n. Okay. Number of subsets. To find number of subsets, we have the formula 2 power n. Here n is nothing but the number of elements. Okay. Let us see. 2 power n means number of elements in the given sets. How many elements are there in the given sets? 3 elements are there. So n is equal to 3. So it means 2 cube. 2 cube value, how much it is? 8. It means from this set, we get total 8 subsets. Okay. So let us see what are they. They are. So we all know that empty set is subset to every set. Okay. While discussing empty set, subset, and we have discussed everything this. Okay. So empty set is subset to itself. Empty set is subset to every set. Empty set is denoted by the symbol y. Okay. And every set is subset to itself. Okay, here the name of the set is C. So every set is subset to. Now write the elements. First of all, you take single elements. Okay, first of all, set of x. Next, set of y. And next, set of z. Single elements we have taken, completed. Now take double elements. First x and y. Okay. xy after next xz. X comma z. So with element x, xy completed and xz completed. Right? Now take the second element, yz. Okay. The last element z is there. We cannot form a pair with this element z. So these are the possible subsets from the given set. Total how many subsets we should get? 8. So let us see, 8 is there. 1, 2, 3, 4, 5, 6, 7, 8. Okay. It means from this given set, we get total 8 subsets. One is empty set and second one is every set is subset to itself and the remaining these are the sets. Okay. So this is the way of finding number of subsets and subsets, right? Let us see one more problem. Okay, children. So in the same way, you complete the remaining problems, children. Already we have discussed while discussing what is subset. So to complete the remaining problem, in the next class, we can learn the next exercise. Okay. Thank you, children. Thank you.
Slide share. Slide share you want.
Good afternoon, one and all. Welcome to Shanvi Learning Services. Welcome to biology class, lesson number 2, respiration. Please be attentive, all of you. See here, we are in the topic of gases exchange. Okay, so gases exchange takes place within the lungs by diffusion. Okay, gases exchange takes place within the lungs by diffusion from the alveoli to blood capillaries. So as we know, gases exchange takes place at the lungs level. Okay, gas exchange takes place at the lungs level. So here, gas exchange takes place within the lungs by diffusion process. So what is the diffusion, sir? What is the diffusion? So simply here, diffusion is a movement of air. Okay, diffusion is a movement of air from an area of high concentration to an area of low concentration. Okay, so gases exchange takes place within the lungs by diffusion from the alveoli to blood capillaries. So alveoli is a plural. Like alveoli is a air sac like complex structures which are present in the lungs. Okay, so here the gas exchanging taking place within the lungs by diffusion process from the alveoli which is present in the lungs to blood capillaries. Okay, in blood capillaries, blood will flow. Next, see here, look at the screen, all of you. Lungs in the vertebrates. Lungs in the vertebrates. So what are the vertebrates? Which will have the vertebral column. So we also comes under vertebrates because we will have backbone, vertebral column. So lungs in the vertebrates are made of several thousands of small chambers called alveoli. Alveolus is a singular, alveoli is a plural. So lungs in the vertebrates are made of several thousands of small chambers. Several thousands of small chambers are present in the lungs. That small chambers, air sacs, are called alveoli. Alveoli. Next, lungs in the vertebrates, as we have discussed just now, are made up of several thousands of small chambers called alveoli. Here, look at the screen. Left side, alveolus are given clearly. Alveoli is given clearly. Now, see here, alveoli is the structural and functional unit of the lung. Okay, alveoli is the structural and functional unit of the lung. Look at the screen how alveoli and how the blood capillaries are there. Now, here each alveolus, singular, each alveolus is supplied with a branch of bronchiole. The branch of bronchiole and with capillaries, with blood capillaries, which brings the deoxygenated blood. Okay, each alveolus is supplied with a branch of the bronchiole and with capillaries, which bring the deoxygenated blood. See here, when exchange of gases happens at the lungs level, the blood cells are carrying the oxygen to the cell, like tissue level. Their cellular respiration is taking place. Then in the cellular respiration, three things are releasing. One is carbon dioxide, one more energy, and one other one water. That carbon dioxide again bring back to the lungs level by the blood, which will float in the blood capillaries. As you know, when it's bring back to the lungs, then from blood capillaries by the diffusion process, carbon dioxide will move from the blood capillaries to the alveoli of lungs, and from the alveoli of lungs to the blood capillaries oxygen. So like that, oxygen to the blood capillaries and carbon dioxide to the lungs, like that exchange, gases exchange is taking place. Gases exchange is taking place. Okay, children? Next one. Each alveolus is supplied with a branch of bronchiole and with capillaries, as we discussed just now, which brings the deoxygenated blood. See here, blood dark comma red in color. Blood dark comma red in color flows from the heart. Through these capillaries. And collect oxygen from the alveoli. Okay, now look at the screen, all of you. Blood dark comma red in color flows from where? From the heart. Okay, blood dark comma red in color flows from the heart through these capillaries, and that can collect oxygen from the alveoli. Look at the screen. Air in and out. So oxygen in, carbon dioxide out. It is clearly shown with arrow mark, light blue, thick blue. Oxygen in, light blue, and thick blue, of carbon dioxide out. So this exchange of gases. And red blood cells in capillaries. See, blood also tissue consists of number of cells. So red blood cells in capillaries, floating in the capillaries, and alveoli, that particular dome shape like alveoli, and oxygenated blood out. Oxygenated blood is out. Like blood is carrying that oxygenated blood. Blood is carrying that oxygen. So which blood is consists the oxygen, that is oxygenated blood. It will reach this tissue. Okay. Then when tissue, there is a particular blood cells reach the tissue, this oxygen is utilized by the cells for the cellular respiration. As I have told just now, it involves in the respiration process and release the energy and produce water and carbon dioxide. Then carbon dioxide again bring back to the lungs level. Like this process is going on. Okay. See here, blood dark comma red in color flows from the heart through these capillaries and collect oxygen from the alveoli. At the same time, carbon dioxide passes out of the capillaries. Carbon dioxide passes out of the capillaries. Okay, out of the capillaries. To where? To the lungs. And into the alveoli. When we breathe out, we get rid of this carbon dioxide. At the same time, carbon dioxide passes out of the capillaries. Carbon dioxide passes out of the blood capillaries and into the alveoli. Where alveoli is present? In lung. So at the same time, carbon dioxide passes out of the capillaries and into the alveoli of lungs. Okay. So when we breathe out, we get rid of this carbon dioxide. Carbon dioxide can be removed from the exhale. When we breathe out, we get rid of this carbon dioxide. Okay. Next, the bright red oxygen rich blood. The bright red oxygen rich blood is returned to the heart. The bright red oxygen rich blood is returned to the heart and pumped out to the body. So, which blood is like reaching the heart? The brighter red oxygen rich blood is returned to the heart. After from that heart, it is pumping to all the body parts. It is pumping to the from heart. It is pumping all body parts. Okay. Then that oxygen bed is reaching to the tissue level. There, this oxygen can be utilized for the cellular respiration. As usual, it is releasing the energy and producing the water and carbon dioxide. Okay, that there is no need of carbon dioxide at that place. So that carbon dioxide will be bring back with help of that blood to the lungs. Then at the lungs level again it will be like exchange will takes place. Carbon dioxide to the lungs and oxygen to the capillaries. Like that exchange will takes place. Okay. Now see here, the bright red oxygen rich blood is returned to the heart. It is shown on the screen. Please look at screen. Look at the screen. Love you. The bright red oxygen or rich blood is returned to the heart and pumped out to the body. Pumped out to the body. Okay. Here, oxygen is given. Carbon dioxide is given, blue color like light carbon dioxide and the red color oxygen shown in the figure. Next, as a result of a gas exchange, the composition of inhaled and exhaled air is different. So what is the composition, sir? Here you need to know about the composition. For example, your mother prepared a cup of tea, right? So what things are to be added in that? Like 1 cup of milk or 1 tea glass of milk or half glass of milk and half glass of water and 1 tablespoon of sugar and 1 tablespoon of tea powder. So these all are composition of that particular cup of tea or 2 cups of tea. Okay, and what percentage is? Okay, that is a composition. Here, as a result, gas exchange, the composition of inhaled and exhaled air is different. See, in inhaled air, oxygen is present, carbon dioxide is present, and nitrogen also present. What about in exhaled air? Likewise, carbon dioxide is present, oxygen is present, and nitrogen also present. Don't think we are exhaling pure carbon dioxide and don't think we are inhaling pure oxygen. Okay, so I will show now the percentage of particular components in our inhaled air and in our exhaled air also. Fine, did you get that? What is the composition? As a result of gas exchange, the composition of inhaled and exhaled air is different. The percentage of nitrogen, oxygen, carbon dioxide is different in between inhaled and exhaled air. Okay, but here nitrogen we can expect same in inhaled air 78% and in exhaled air 78%, but there is a change in between oxygen and carbon dioxide. Nitrogen will be same, then rest of the oxygen and the carbon dioxide will be different in that composition of inhaled air and exhaled air. Okay, so with respect to the carbon dioxide and oxygen, here statement is given. The result of gas exchange, the composition of inhaled and exhaled air is different. Let us go for that. What is the composition of inhaled air and exhaled air? what is the percentage of nitrogen, carbon dioxide, and oxygen? And in inhaled air, and likewise in exhaled air also, what is the composition of oxygen, nitrogen, and carbon dioxide, CO2? Okay. Let us observe the given table to get the composition of inhaled and exhaled air, percentage in inhaled air and percentage in exhaled air. What gases are present in that inhaled and exhaled air? Oxygen O2, carbon dioxide CO2, and nitrogen N2. Okay, so here oxygen is present, carbon dioxide is present, and nitrogen is present. So likewise, three gases are present in that inhaled air and exhaled air. Then whatever the percentage in inhaled air and percentage in exhaled air. See here, oxygen percentage in inhaled air 21%. 21%. Okay, and oxygen 21% in inhaled air. Whatever carbon dioxide 0.04%. 0.04%. And nitrogen 79%. In old books, the carbon dioxide given 0.03% and nitrogen 78%. Okay, please consider that. Here, oxygen 21%, carbon dioxide 0.04%, and nitrogen 79%. Okay, and what about in percentage of in exhaled air? What are the percentages of gases? Oxygen 16%, carbon. So oxygen percentage of inhaled air 21. What about exhaled air 16? Carbon dioxide percent of in inhaled air 0.04%. Percentage in exhaled air 4%. What about nitrogen 79% in inhaled air and in exhaled air 79% as it is. So it means what we are inhaling in that air, oxygen, carbon dioxide, nitrogen is present, and we are taking what amount of air we are taking in inhalation, that if you consider as 100%, from that 21% of oxygen is present, 0.04% is carbon dioxide, 79% of nitrogen. Did you get me? Likewise, what amount of air you are breathing out, that is exhaled air, this particular oxygen is present, carbon dioxide is present, nitrogen is present. What are the percentages of the gases are breathing out in your exhaled air? Oxygen 16%, carbon dioxide 4%, and nitrogen 79%. Okay, children? And next one, next heading is transportation of gases. Transportation of gases. Let us go to know the transportation of gases. Now, look at the picture, all of you. The relative amount of gases, and their combining capacity with hemoglobin. The relative amount of gases and their combining capacity with hemoglobin Hb. And other substances in blood determine their transport via blood in the body. Okay, now got it? The relative amount of gases and their combining capacity with who? With the hemoglobin Hb and other substances in blood determine their transport via blood in the body. Blood in the body. See here, look at the screen that here. Relative amount of gases and their combining capacity with hemoglobin and other substances in blood determine their transport via blood in the body. Now here, when oxygen present in the air, when oxygen present in the air is within normal limits, then almost half it is coiled in the body by binding to hemoglobin. When oxygen O2 present in the air is within normal limits. Okay, when O2 oxygen present in the air is within normal limits, then almost half it is coiled in the body by binding to hemoglobin, Hb plus O2. Okay. See, a protein present in the red blood cells. A protein material present in the red blood cells, as oxygen is diffused from the alveoli of lung to the blood capillaries. As you know, in the blood capillaries, blood cells are like floating. Blood cells are floating is taking place. So when oxygen diffusing from the alveoli of lung to the blood capillaries, okay, a protein present in the blood cells, as oxygen is diffused in the blood from alveoli of lungs, it rapidly combined with the hemoglobin to form oxyhemoglobin. Okay. So why it is combining a protein material? A protein is present in the red blood cells. Red blood cells. As oxygen diffused from the alveoli of lungs to the blood, just present in the blood capillaries. It rapidly combined with the hemoglobin to form oxyhemoglobin. Hb is a hemoglobin, O2 is oxygen. Hb plus O2 gives rise to HbO2. Oxyhemoglobin. When it is diffused into the blood, what? Oxygen. When oxygen diffused into the blood, rapidly combined with hemoglobin, because in red blood cells, the pigment is present, that is hemoglobin. So this particular oxygen, when enters into the blood, rapidly it will combine with the hemoglobin. Oxygen combined with the hemoglobin to form oxyhemoglobin. Okay. Don't read that hemoglobin oxygen. That is a oxyhemoglobin. Hb plus O2, HbO2, oxyhemoglobin. Okay. See, oxyhemoglobin. Look at the screen. Hemoglobin plus oxygen, oxyhemoglobin. Not only can hemoglobin combine with oxygen, children, but the reverse can also happen to yield a molecule of hemoglobin and oxygen. Okay. Not only hemoglobin combined with the oxygen, but the reverse can also happen. To yield a molecule of hemoglobin and oxygen. See, look at the screen. A beautiful picture on the screen. CO2 is usually transported as bicarbonate. HCO3. CO2 is usually transported as a bicarbonate. While some amount of it combined with hemoglobin, and rest is dissolved in the blood plasma. Okay. CO2 is usually transported as bicarbonate, HCO3. CO2 is usually transported as a bicarbonate, while some amount of it combined with hemoglobin, and rest of that is dissolved in blood plasma. Okay, see here clearly shown on the figure. Look at the screen. Clearly shown in the figure. Please look at the screen. How that amount of particular carbon dioxide combined with hemoglobin and rest of dissolved in blood plasma. See here, right side in circular. It is showing like how it is dissolved in blood plasma. Okay. Then next, look at the screen, all of you. As I have told you just now, rapidly when oxygen diffuses from alveoli of lungs to the blood capillaries, nothing but to the blood, then hemoglobin rapidly combined with oxygen, right? Oxygen combined with rapidly combined with hemoglobin, Hb plus O2, HbO2. Hb plus O2 gives rise HbO2, oxyhemoglobin. As this, reverse can also happen, as I told just now. Reversible reaction also can be happen. Oxyhemoglobin can divide like hemoglobin and oxygen. If it is not happens, how the oxygen is supplied to the cell when the blood cells reaches the tissue at a cell level, like that cells to involve in the respiration process required oxygen, some amount of oxygen, right? That oxygen can be taken from the oxyhemoglobin. So at that time, oxyhemoglobin HbO2 can be divided as Hb plus O2. This O2 can be utilized for the cell to involve in the respiration process. That is cellular respiration. To release the energy. So what is the use of respiration, cellular respiration? Will release the energy. Okay, that's why here hemoglobin plus oxygen, it gives rise to oxyhemoglobin HbO2. As this, it can be done in reversely also, like HbO2 gives rise to Hb plus O2. Okay. Now, here gases exchange capillaries to cells and back. Gases exchange capillaries to cells and back. This topic we can discuss in next session. Let us go for feedback. Let us recall what we have learned today. If you please stay online. See, as we have discussed how exchange of gases is taking place in between alveoli and blood capillaries. What are the alveoles? Alveoles are structure and functional unit of the lungs. Okay, and how the oxygen is and oxygen and carbon dioxide exchanging at the lungs level. We have learnt, and the bright red oxygen rich blood is returned to the heart and pumped out of the body. Oxygen rich blood can be pumped out to the body from the heart. Okay, after filling that oxygen, blood can be carried out to the heart. From heart, it will be pumped out over all the body parts. Okay, and here the bright red oxygen rich blood is returned to the heart and pumped out to the out of the body. As a result, the gas exchange and the composition of inhaled and exhaled is different. So we have here one table, the percentage of inhaled air and the percentage of exhaled air, and what is the composition also, you know that now. The percentage of components present in the particular inhaled air and exhaled air. Exhaled air, here oxygen is present, carbon dioxide is present, and nitrogen is present. And what are the percentage of oxygen, carbon dioxide, nitrogen in the percentage of inhaled air, and whatever in percentage of the exhaled air? We have learned that. Next, transportation of gases. The amount of gases and their combining capacity with hemoglobin and other substances in blood determine the transport via blood in the body. Okay, and the oxygen how like present in the air is within normal limits. Then almost of it cold is the body by binding to hemoglobin. as we discussed how the hemoglobin is binding to the oxygen. Okay, how the air is like oxygen is diffusing from the alveoli to blood, and when oxygen diffused from the alveoli of lungs to the blood capillary, rapidly it will combine with the like the oxygen rapidly combined with the hemoglobin. So here we have a clear reactions like hemoglobin reacts with oxygen, forms oxyhemoglobin HbO2. So reverse also can be happen. HbO2 can divide like Hb plus O2. And here CO2 is usually transported as bicarbonate HCO3 bicarbonate, while some amount of it combined with hemoglobin and rest of the dissolved in the blood plasma. Here clearly given in that circular. Okay. So this is our topic and what we have learned today. Okay. In next session, let us meet with beautiful slides on topic of gaseous exchange capillaries to cells and back. Okay. Thank you.